Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about 8051 SFR register, that is special function registers. Look at this. Actually, this is the internal RAM. Inside this is the special function register. This is from 80 to FF. This will be mapped with the locations. So it consists of timers, serial ports, interrupt systems, that is an interrupt structures registers, and then A to D converters. Activity converter is available in higher versions. Basic 8051 there is no A to D converters will be available. Similarly, digital to analog converters, this is also not available. Basic of 8051, higher versions it will be available. So we use this address from 80 to FF. This SFR register we use direct addressing modes. Look at this mapping. Look at this actual address. This is 80. This will be mapped with the port 0. So this is a port 0. So this 80 is a byte address. The bit address for this port 0 is 80, 81, 82, 83, 84, 85, 86, 87. That means individual bits will be accessed by bit address. Entire bytes can be accessed with byte address. So if I use the bit address 80, what happens? This port 0, that is P0.0 will be accessed. Similarly, if I use P0.1, this 81 address will be accessed. So these individual bit will be accessed. So in SFR, some registers are bit addressable, some registers are not bit addressable. So this is bit addressable. Look at this. So this register, this TCON, this P1, SCON. So these will be have a bit addressables. So like this DPL, SP, these are not bit addressable. So that means this register, it supports both byte and bit addressing. So all the registers have a capacity of byte addressing. So only few registers have the capacity of both byte and bit addressing capacities. Look at this. So 80 byte address, it have port 0 as ports, and this bit address is from 80 to 87. This is SP stack pointer. This is don't have a bit address, only byte address. This is 81. Look at this data pointer. So data pointer lower and data point higher. This is 82 and 83. So these two only combine to access that particular data. So data pointers. Look at this. This is a PCON register. This is the address is 87. So this is also not bit addressable. So only we can use it the byte address. Next will be TCON. This is a bit addressable. So look at this. This 80, that is 88, and look at this 88 to 8F. So byte address is 88 and bit address is from 88 to 8F. That means individual bits. This is a TCON.0, TCON.1, 2, 3, 4, 5, 6, 7. So from TCON.0 to TCON.7, 8 registers will be, that is 8-bit address will be accessed. So we can use an byte address 88 to access all the bits, or if I want the individual bits, I can use that particular address. If I use this 88, that indicates this TCON.0, or I can take it as a byte address of 88H.0 location. Both will be same. Look at this timer mode control where this is also not bit addressable. So look at this timer lower and higher bit. So this is TH1 timer higher one, TL1 timer lower. So this will be one or two will be for a timer 1. TH0 and TL0, this is for a timer 0. This is a timer 0 lower and higher bits. That's why we take it as a L and H. T indicates a timer, L indicates a lower or higher, and 0, 1 indicates a timer 0 or timer 1s. So all these 4 bits are not a bit addressable location. The address is 8A, 8B, 8C and 8Ds. Look at this port 1. Port 1 is both byte address and bit addressable. 90 is a byte address and bit address is from 90 to 97. Look at this SCON. So SCON is a bit addressable. So from 98 to 9F this is a bit addresses, and then 98 is a byte address. Look at this. This is an SBUF, that is a serial buffer. So this is not a bit addressable. So address is 99. Look at this port 2. So both bit address and byte address possible. A0 is a byte address. From A0 to A7 it is a bit address for individual bits. IE interrupt enable bits. So this is also bit addressable. Look at this. A8 is a byte address and A8 to AF is a bit address. Look at this port 3. So B0 is a byte address. So B0 to B7 is a bit addresses. Look at this. This is an IP, that's an instruction pointer. You have the addresses from a B8, B9 up to BC. So this is an byte address is a B8 and then bit address from a B8 to BC. Look at this program status word, that is a flag registers. So D0 to D7. So there will be a D address. Actually, the D0 will be an byte address. So from D0 to D7 is a bit address. So look at this accumulator. This is an E0. So E0 to E7 is a bit address and E0 as the byte address. From B register, this is also bit addressable. F0 to F7 is a bit address and F0 as a byte address also. So these individual bits can be accessed with the bit addressables. Look at this actual mapping of 8-bit. Look at this. So 80, this is a port 0. So 88 is mapped here as a TCON registers. Look at this. So this is the P1, SCON, P2, IE and P3 IP. So these will be corresponding, it will be applied and then out for this values. Look at this. This is the 80 to F8. So this is 87 to FF. So actual values so will be mapped in the registers. So this is an actual 8-bit mapping of SFRs. That is an SFR memory mapped registers. Look at this. This is the bit address for this individual registers. So if you see one similarities, I can show here easily. Look at this. So this address 80, same address 80. If you say this 88 and this is 88, that indicates the byte address and bit address of the lower bit will be same. So that's here also mapped. Thank you.